everyone, welcome back. We are still in the process of deriving normal shock relations. We stopped at some point there. I will just take one step back and then continue from there. I just want to put one more point on the board which I pointed out sometime earlier last class, which was that we had this relation and I said as a note that if I put P1 equal to P2 and U1 equal to U2, this equation is satisfied, okay. But if I do that, my P2 by P1 will become 1, which will make my rho 2 by rho 1 1, which will make my U2 by U1 1, which will make my T2 by T1 1, everything will become 1, which means no change in flow properties. That is a very special case, that is also a solution to this equation, okay. We will remember that, we will go back and look at that towards the end of today's class, we will come back to you there. Now we want to eliminate all variables, pressure, temperature, density, velocity, everything in terms of Mach number. That is our ultimate goal, of which we started here. We had this relation, constant area momentum equation, a special case, but it is valid for us because we are thinking across a shock which will be a very thin layer anyway. So, I can put a very thin control volume around it and I can say it is constant volume also, okay. Now, if I rewrite this, this is still just one equation, momentum equation. I will use this sorry, it is the opposite. Gamma p by rho is a square is what I am going to use, and similarly for 2. So, I will just remove this subscript, I can put 1 or 2 as subscript depending on whatever is needed. I am going to use the definition of a square and along with this the state equation, both have been used here inside here itself. If I use that, this rho by p will become gamma by a square, in this case it is gamma u1 square by a1 square, which will become gamma m1 square. So, I will get to a relation which looks like this, p2 by p1 will become 1 plus gamma m1 square by 1 plus gamma m2 square. This is not new, you have seen this even last class. Till here everything is last class also we did this, okay. This is one relation and this is the other piece. We have this one where we said there is a trivial solution sitting inside where there is no change in the flow, and here I am getting P2 by P1 in terms of M1 and M2. Now what we want to do is, I have actually used momentum equation and state equation and a square definition here to get to this point. Now we still have mass equation, energy equation left, okay. Now I will go and look at deriving P2 by P1 in some other form using the remaining equations and then equating that to this, that way I will eliminate P2 by P1 also. So I will just have an expression for M2 by M1 and M2 in terms of mass and energy equation on this side, and other side I already have M1 and M2, I will equate those two, that is the goal. So I am starting with mass equation. Now I will write this velocity in terms of Mach number definition. Sorry, it should be M1. I have this relation. Now I still have to express rho t in terms of Mach numbers, that is the overall goal. Now I want to write this in terms of P2 by P1 because I have a simple expression for P2 by P1 in the previous board, right. So, I will write rho as P by RT. So, I will come out to P1 by RT1 and I will just remove this square root of gamma r from both sides, they are equal anyway, the square root of T1 and square root of T2 still remains. Okay. Where this r can also be cancelled. Now, I am having a little simpler expression. I will write this as P2 by P1, P2 by P1 will be equal to M1 by M2 times square root of T1 in the denominator finally here, and this will come out to be square root of T1 T2 in the numerator, T2 by T1. I will get to this form. Now, I already know something about this. I know that this is equal to from here 1 plus gamma m1 square divided by 1 plus gamma m2 square. I will use this in terms of in place of P2 by P1. So, as of now I have a relation here, if I just look at these two terms, I have a relation here in terms of Mach number alone except for T2 by T1. Now, this T2 by T1 I know that T naught is a constant for the whole fluid or for the whole flow. So, I can write this in terms of 1 plus gamma minus 1 by 2 m square. So, that is what I will do here. So, it will simplify to, I will take a square of this whole thing because square root I do not like ever. So, I will write it as m2 square by m1 square. I am taking this ratio that side and everything else this side. So, I will have 1 plus gamma m2 square, 1 plus gamma m1 square, this whole square because I have squared the previous equation times I will have T2 by T1, I have squared it. So, T2 on the numerator will be equivalent to T2 by T naught divided by T1 by T naught. So, it will be equivalent to T naught by T2 in the denominator, T naught by T1 in the numerator. So, I will write T naught by T1 m1 square divided by 1 plus gamma minus 1 by 2 m2 square. So, I am finally having a relation just relating m1 and m2, which is what we wanted, but it is still not very simple. We have to simplify this such that I can write it as m2 equal to a function of m1 alone. That is the overall job and that is what we are going to do today. Okay. So, I have to solve for m2 in terms of m1 from here. What do I have to do? It looks like it is not very easy to do, but if you look at this, it is a plus b square multiplied by some b plus d or something like that. That is all we are having here, simplified form. So, I will just multiply out all the numerators, multiply out all the denominators and then group all the terms together, that whole thing we are going to go through. Okay. So, we will start writing. Now, I am going to be using more space on the board, I will be more careful about the length. This term is just 1 plus gamma m2 square whole square, that is the only thing I have written here as of now. And of course, I have the same thing with the m1 in the denominator. So, I will just write that immediately. Multiplied by the remaining term, I will just rearrange that as slightly multiply and divide by 2 and I will get to this form. The good thing about this equation as of now is numerator and denominator look exactly the same except for m1 replaced by m2 and m2 replaced by m1. Okay. We have always been having this kind of symmetry, we will just keep maintaining it. which will help us in finding any errors if we make any. Okay. Now I have to multiply this with this, a plus b plus c multiplied by d plus e, that is going to have 6 terms total. So I will write all the terms out, I will give more space. These 3 terms are coming from 2 multiplying these 3. Now I will write the terms for this m1 square times gamma minus 1 multiplying this whole 3 terms. We will keep gamma minus 1 in bracket for now. Even then I do not have space. Let us see if I can just squeeze this one term here. This whole term is sitting here. Okay. That will be the last term, gamma square m2 power 4 multiplied by gamma minus 1 m1 square. It is 1, 2, 3, 4, 5, 6 terms there. The same set of terms will be in the denominator, just replacing m2 by m1 and m1 by m2. So I will try and conserve space here. Only the last term will look slightly different, it is m2 square, here it is m1 square, m2 square m1 power 4, here it is m1 square m2 power 4. Okay, again 1, 2, 3, 4, 5, 6 terms. Now this is not enough, we have to bring it to a form which is even more simpler. So what I have to do now is take the denominator, multiply it with m2 square, take this m1 square, multiply it out with this numerator, and then take all the terms to one side, other side should be 0. That is the overall thing we have to do. Okay. Let us try and do this with grouping the terms already. So I am going to look for all the terms that have m2 power 4 in it. I am going to look for all the terms that have m2 power 4 in it. Okay. Every term I am going to have I will consider. So m2 square is here, any term that has m2 square here, if I take it to that side will have m2 power 4. So I am going to look for this term, that is a gamma minus 1, so I will keep that, and then this whole term multiplied by m2 square is there, that m2 square with this m2 square will give you m2 power 4. So I am going to have another m2 square is sitting here, gamma square gamma minus 1 m1 power 4 multiplied by m2 power 4 it will come. So that will be this is all just coming from denominator multiplying m2 square. Now I may have other terms coming m2 power 4 from here, that is this term and the last term, 2 terms have m2 power 4 and they will come to this side with a minus sign. So I will keep another bracket here, this is all coming from numerator. Now for denominator I have 2 terms, so I will put a minus and then look at what those terms are, m1 square multiplied by 2 gamma square. Okay. So it will be 2 gamma square m1 square plus one more term is there, that is m2 power 4 in this corner, that will be multiplied by an m1 square from this side coming there. So, it will become m1 power 4 gamma square times gamma minus 1. This whole set of terms are all coefficients of m2 power 4 only. Now, do we have m2 power 3 anywhere? We will not have any m2 power 3 terms, because every m has a square or power 4 on it. So, there is no odd power. Okay. Every m2 is having square or power 4. So, there will never be a power 3 on this corner. So, there is only m2 power 2 now. Okay, of course, this whole bracket plus, I am writing one big equation folded into 4 pieces. Okay. This is all m2 square terms collected. Okay. Now, of course, 2 times m2 square is directly one term there, 4 gamma m1 square multiplied by m2 square, that is another term there. This is again multiplied with this, another term there. This will not occur, this will, we have already used these 2 terms, we have already used this term also. So, I will actually put a tick for all the terms I used already. These 3 terms I used, that is 1, 2, 3 terms here, and then on the numerator I have used this term and I have used this term. Only the remaining terms I need to be using. These 3 terms are all going to be multiplying this m2 square, so they can directly come here. I will again put another bracket for whatever came from denominator. Minus whatever is coming from the numerator. I am again looking for m2 square terms. This is m1 square going and multiplying. So, whichever term here has m2 square will be used. Oh, by the way, now I have used all the terms in the denominator. I will put double tick because it is on the second iteration, second set of terms, second floor bracket if you want to think about. Okay. Now, m2 square will be this term and this term. So, it will be 4 gamma m1 square and m1 square multiplied by this, which is 2 gamma into gamma minus 1 into m1 power 4. And there is no other term left. This is all I will have. This is the next term. Now, there is no more terms left in the denominator. Only thing left will be all the other terms which are not dependent on m2. We will put all of them together. I will just put one just so you know that it is m1 m2 power 0 if you want. Okay. There is nothing coming from the denominator, just to show that I will put a 0. Same bracket, first bracket is from denominator, nothing is coming from the first bracket, every term is used up. Only set of terms left are this 2 gamma minus 1 m1 square, only 2 terms are left, that is multiplied by m1 square and taken to the left side. So, there is a minus sign here. So, it will be 2 m1 square plus gamma minus 1 m1 power 4. This is the whole set of terms we have. I do not want to put a triple tick here, ones that are left will be the terms that are going here. And all of the terms have been rewritten such that everything is here, then this is equal to 0. This term plus this term plus this term is equal to 0. So, it is an equation folded into 3 lines, that is what I have right now. Now, we want to solve this. Okay. So, we have to simplify these terms. Let us start looking at the first floor bracket. I will write that part alone inside, just I will just call it this, that is my first floor bracket. I want to simplify this term. Anything directly that can be simplified? 2 gamma square m1 square is there, it is also in this place, they are going to get cancelled. Which one? Only this gamma into 2 gamma time. that term will get cancelled with this term. Maybe I will just directly start cancelling, it will just be confusing. Now I will just go outside and do it again, it is not very difficult to do, there is not 2 there. This is what is in the first floor bracket. I am just writing whatever is here there. Now we will simplify just that portion. Of course, now I can cancel this and this, and just so I am cancelling things correctly, I will just connect these 2 lines. This is one cancellation I am doing. Now I am supposed to be looking for this term, m1 power 4 term, and that is here. It looks like they will exactly cancel each other. Okay. So I will just remove these 2 together, cancel the full term. So what is left is much simpler. Okay. I am left with gamma minus 1, and there is this minus 1 times 2 gamma m1 square. So what I am left with is gamma minus 1 minus 2 gamma m1 square. This is my first floor bracket in this big expression. Now we will go and pick up the next one. Of course, we have to write the full expression with m2 power 4 later. We will go pick up the next one. So the next floor bracket is going to be this is the full expression, and we have to simplify this. If I look at this one, I can directly cancel 4 gamma m1 square with 4 gamma m1 square. I will again keep that connection line so that we know we are cancelling correct terms. And then now I am seeing 2 gamma square m1 power 4, 2 gamma square m1 power 4. Of course, the minus 1 times 2 gamma is still remaining. So I will just cancel this with this. I will connect these 2 together. So the remaining terms, they are just going to remain, and that is going to look like 2 and then minus 1 times minus 2 gamma. So it will become plus 2 gamma m1 power 4. This is your second floor bracket. This is what I am having here. Third floor bracket is nothing great, I do not need to simplify this so much. We will just keep it like this, nothing is going to get cancelled, we will just keep it like this. Okay. So now I will write the full expression for m2 power 4 equation. m2 power 4 times first floor bracket, which is gamma minus 1 minus 2 gamma m1 square, plus second floor bracket times m2 power 4, m2 square, sorry, and that is 2 plus 2 gamma m1 square, m1 power 4, sorry. Okay. And plus the last term, but it has a minus sign in front of it. I will put this minus 1 outside, and also I will pull out a minus m1 square, okay, just so it looks, at least it looks like 2 plus gamma minus 1 m1 square, we will keep it that way. So it will become minus 2 m1 square minus 2 m1 square times no, there is no 2, sorry, if I pull out a 2 then it will be gamma minus 1 by 2, we will keep it like this. minus m 1 square is what I am pulling out, we will keep 2 plus gamma minus 1 m 1 power 4, this whole thing equal to 0. Whatever I wrote in 3 lines has now become almost one line equation, okay. That is what I have brought it down to. Now, if I look at this expression, it is actually m 2 power 4 m 2 square no function of m 2 equal to 0, m 1 square, okay, yeah, thank you, this is actually m 1 square, I have pulled out m 1 square there, it should be m 1 square, I have it right here, I copied it wrong, okay. So, now we have an expression m 2 power 4 multiplied by something constant, as far as m 2 is concerned it is a constant, okay. M 2 square and then just a constant equal to 0. This is a quadratic in m 2 square. So, we have to write expression for m 2 square from what we know from quadratic equation. We are going to solve quadratic equation, it will be what, minus b plus minus square root of b square minus 4ac by 2a is the solution for which equation, ax square plus bx plus c equal to 0, okay. So, we are going to use that whole thing here. So, you have to try and group things, but we will group that after I write it once here. M 2 square, that will be my variable here, right, for quadratic equation m 2 square is my variable, m 2 square square is what is here, m 2 square is given by minus of the second coefficient 2 into 1 plus gamma m 1 power 4 plus minus square root of this square b square, right. So, it will be, I will take out the 2 because it is going to get cancelled soon. I have squared the 2 and put a 4 here, remaining things are sitting here, minus 4 times first coefficient into last coefficient, that is how it is supposed to be. So, if I look at 4 times this into this with a minus sign, there is a minus sign here, they will go away and it will become plus, put plus 4 m 1 square into 2 plus gamma minus 1 m 1 square, this thing multiplied by the first coefficient gamma minus 1 minus 2 gamma m 1 square. I will just write this m 1 square above and then close bracket around this. I do not have space for the final thing, it is 2 gamma m 1 square there, that is basically this term there at the end, square root extends all the way up to the end. This is just the numerator, I have to put divided by 2a. Two into just the first coefficient gamma minus 1 minus 2 gamma m 1 square. I said the 2 is going to get cancelled here, so it is a nice point to cancel it, okay. I will just take this 2, divide the numerator with it, this 4 will come out of square root and become 2. So, I am just cancelling this 4, this 4, this 2 with this 2, all that is cancelled. Now, the remaining thing is my solution, it is not easy to solve, but that is my solution, okay. I have m 2 square in terms of m 1 square or m 1 power 4, that is what I have. In a way this is the solution. We will try and simplify this a little more, we will just go and look at what is inside the square bracket, inside the square root and see what happens inside here. I will go to the other corner. So, the term inside the square root term, whatever is inside only I am writing, okay, whatever is inside the square root, it is going to look, basically I will write the first full term inside, square plus m 1 square times 2 plus gamma minus 1 m 1 square multiplied by gamma minus 1 minus 2 gamma m1 square. This is the term that is present. I just want to multiply it all out and write out the full expression, and then we will start grouping them again. As of now, it is a plus b whole square. So, it is going to be 1 plus 2 into this 2 gamma m1 power 4 plus gamma square m1 power 8, we have gone all the way up to 8 now, plus I have to multiply things. I will keep this gamma minus 1 as a group because it is easy to work with gamma minus 1. Okay. We will keep it like that for now. This gamma minus 1 is kept as a group. It could be just gamma multiplied separately, 1 multiplied separately. We will keep it as a group, it is simpler to work with. So, I am taking this and this multiplied with m1 square, that is one term. Next term will be gamma minus 1 multiplied with the second one multiplied with m1 square, which will be m1 power 4 into gamma minus 1 square. I do not need a bracket there, it is just m1 power 4. That is just gamma minus 1 multiplied with these two. Now, I have the remaining two terms. I will write that minus 2 gamma m1 square multiplied with 2, it will become minus 4 gamma m1 square into m1 square m1 power 4. I am starting to write in the second line, it is still just one line equation. Okay. Multiplying this with this will give me minus 2 gamma into gamma minus 1 into m1 square m1 square m1 square m1 power 6. Okay, I have m1 power 4, m1 power 8, m1 power 2, m1 power 6. Okay. This is a whole set of equations we have. Now, look at these two. Okay. So, these two can be replaced with one term which is minus 2 gamma m1 square, m1 power 4, sorry. Okay. It will just come out to be that. Now, I will rewrite that. I will group my terms in a nice way so that I can simplify this further. I am going to write it as gamma m1 power 4 whole square, which is what it was originally, this term. I did not write this minus 2 gamma m1 power 4 yet, I will write it next, but before that I will write this gamma minus 1 m1 power 4 term. Okay. I will write that as gamma minus 1 m1 square whole square. Okay, of course, 1 can be written as 1 square, I do not want to write it that way, you just keep it like this. Now, I will write this minus 2 times gamma m1 power 4. That is one term. Now, the remaining two terms are this one and this one, m1 square term and m1 power 6 term. So, I will put that plus 2 gamma minus 1 m1 square minus 2 gamma minus 1 m1 power 6. These are the terms. I have written it in a nice way because I want to simplify the next step. So, when I write it like this, if I look at this term, this can be obtained by multiplying this with this without the square, that is gamma m1 power 4 multiplied by 1 multiplied by 2 will give you this term. Okay. Of course, there is a minus sign, remember the minus sign also. Okay. And then I look at this one, this is gamma minus 1 m1 square only inside the square, that term multiplied by this 1 square where 1 is there multiplied by 2, this is a plus sign, that is here, and then I have this term which is gamma m1 power 4 multiplied by gamma minus 1 m1 square, that is giving you your m1 power 6 multiplied by 2, and there is a minus sign. Okay. So, it is of the form a square plus b square plus c square plus 2ab plus 2ac plus 2bc. Okay. This is of this form. This is equal to a plus b plus c whole square. that is what it will come down to. Yeah, of course you can multiply this and find out that it is correct, it is correct. Okay. You will get to this particular form. So now my A happens to be 1, okay, and then of course these 3 terms are A square, B square, C square terms. Now one of the terms is having a minus sign. Which one will it be? It will be this. Wherever there is gamma m1 power 4, there is a minus sign. Okay, wherever there is gamma minus 1 m square, there is no minus sign. Okay, so I am going to say the minus is for this. Okay, that will be minus for gamma m1 power 4 term. So that b square, the b is actually minus gamma m1 power 4. B square happens to be this correctly, nothing wrong with it. So I will write this as 1 minus gamma m1 power 4 plus this term gamma minus 1 m1 square, this whole square. This is what is inside my square bracket, inside my square root. So my whole square root expression will just be without the square, it just simplifies to that. Now I will go and write m2 square in terms of m1 square again. So my original solution to my quadratic, that expression m2 square equal to will become plus minus that bracket which we just found out without the square term, because square root removes it, minus gamma m1 power 4 gamma minus 1 m2 m1 square. Okay, this divided by 2 times the 2 is already divided, cut off, right. So what we will have will be gamma minus 1 minus 2 gamma m1 square. This is what I should get from the quadratic thing. Where is this coming from? From that corner of the board, this equation. We just did what happens to the square root and we gave one bracket for the square root term fully. Remaining terms I am just writing as is in there. So I am coming to this point. Okay. Now we just have to simplify this for case 1 and case 2, plus and minus, those are the 2 things left. Of course if I want I can rewrite this a little bit more, multiply numerator and denominator with minus 1, so it looks a little easier to work with. So I will do that. Ideally I should write it as minus plus if we want to worry about which solution is first and stuff. We won't worry about it really. Since I multiplied the denominator with minus 1, it will become 2 gamma m1 square minus gamma minus 1. Now we have 2 cases we have to solve for. Let us pick case 1. Case 1 I will pick the first sign, let us say I will pick the minus sign. m2 square is going to be equal to 1 plus gamma m1 power 4 minus, I will rewrite the whole thing, so I will just multiply with minus 1 in each of the terms. This is what I have. Can I simplify anything? There is nothing to simplify except this 1 minus 1, just that can be removed, nothing else can be removed. But if I look at this expression, I can simplify it a little bit. Of course I can add these 2 together, this term and this term are exactly the same. So I will write it as 2 gamma m1 power 4 minus gamma minus 1 m1 square divided by 2 gamma m1 square minus gamma minus 1. Look at the numerator and denominator, the answer is supposed to be m1 square. That is all I will have. So, I am getting m2 square equal to m1 square. What are the possible solutions? m2 equal to m1 or m2 equal to minus m1. Minus m1 does not make any meaning for us, except for I can say that the flow is reversed, which cannot happen for us, because mass from this side going into the shock, mass from that side coming into the shock, what happens to all the mass? Mass is not conserved. So, that is not possible. So, the only solution will be m2 equal to m1 from here, but it comes out to be a simple solution. If m2 equal to m1, I already wrote this initial thing, P2 by P1 equal to 1 plus gamma m1 square by 1 plus gamma m2 square. Now, if m1 equal to m2 or m1 square equal to m2 square, this whole thing will become equal to 1. P2 by P1 is 1, we already saw that if P2 by P1 is 1, rho 2 by rho 1 is 1, T2 by T1 is 1, U2 by U1 is 1, that is there is no flow change at all across my wave, comes down to that. So, basically this is the case which I pointed out at the beginning of today's class, where we said if I set P2 equal to P1 and U2 equal to U1, the solution is satisfied, the equation is satisfied. There is a trivial solution hidden inside your equation, and this comes out to be that trivial solution, that is one solution where my flow equations are satisfied with no change in the flow, which is not what we are looking for. We are looking for a sudden change in the flow, we are looking for it. So, we are picking the other solution, we will not consider case 1, we will go to case 2 and consider only case 2. So, my case 2 is the same thing with a plus sign. So, I will write that gamma m1 power 4 plus 1 plus gamma minus 1 m1 square minus gamma m1 power 4. This is my case 2. Here gamma m1 power 4 will get cancelled and all the remaining terms remain, it will become 2 plus gamma minus 1 m1 square. So, m2 square equal to 2 plus gamma minus 1 m1 square divided by 2 gamma m1 square minus gamma minus 1. Cannot be simplified anymore, this is just your relation between m1 and m2. Now, I can rearrange this, I will not go through the algebra here, it is not important. I can rearrange this and go to a point where it looks like I can get it to this form. Okay. Do not worry about how I got to this, just rearranging this I can get to this. I have to multiply and divide by appropriate terms, add and subtract appropriate terms to get to this form. It is possible to get here, not much of use, just for one simple reason I am going to keep it. Okay. You can figure out how to get to this, it is not very difficult to get. Okay. Now, if I set my m1 equal to 1 here, what will happen? This becomes 0, this becomes 0, that does not change anything. I am going to get overall m2 equal to 1, okay, m2 equal to 1. If m1 equal to 1, m2 equal to 1. Now, I will look at the next case, I will write down all the 3 cases. m1 equal to 1 implies m2 equal to 1. If I pick m1 greater than 1, if m1 is greater than 1, then this quantity is positive, this is positive. So, I am going to get some quantity which is positive subtracting 1, subtracting from 1. So, this will be less than 1. Okay. m2 will be less than 1, square root of that will also be less than 1. So, I am writing it like this, but there is one more possibility, m2 if this is greater than 1, sorry, I have to write it as other way, I will write it as m1 less than 1. m1 less than 1, you can show that if this is less than 1, this whole term will become negative and multiplied by minus 1 will become positive. So, 1 plus some quantity square root of that will be more than 1. I will get to this form. This is also possible. Okay. So, now I have so many solutions. m1 equal to 1, m2 equal to 1 is not any great solution, it is just your Mach wave. Why do I say that it is a Mach wave? That is a wave that is going through and it is going at speed of sound. One more thing I have to look at, I already removed the, it is here, okay, we will go back here. If I look at that m1 equal to 1 and m2 equal to 1, I am going to get p2 by p1 equal to 1, which means there is no change across that particular wave. That is your simple acoustic wave called your Mach wave. That is also a possible solution, okay, but it is naturally coming out of the expression. I do not need to worry about it anything special, that is just your Mach wave, nothing great, but we have to understand that that is also a possible solution. If I think about that particular solution, it is not doing anything to the flow, it is just acoustic wave moving at speed of sound at every point, that is all this is. But this one and this one will be very different speeds of the waves, we are going to look for this. Okay. So, now only one of them will be possible in real life, it cannot be that supersonic flow goes to subsonic and subsonic flow goes to supersonic. If I look at my pressure, I will write that same expression here. If I have this expression and I say supersonic to subsonic, this is more than 1, this is less than 1, I am going to get this p2 by p1 more than 1, because this is a big number, this is a small number, okay. I am going to get this whole thing greater than 1. If I pick this case, what does that mean? I am going through a compression, okay. I will call this the compression shock. My wave I already called it as a shock, so I am calling it a compression shock. If I look at the other one, m1 is low, m2 is high, this is low, this is high, I will go through an expansion process, it is going from subsonic to supersonic, okay, and I will get this to be expansion shock. Only one of them is possible. Why? How do I know that? I have to actually know this only from physical intuition. I cannot know it just from looking at the expression. As far as the expression is concerned, it can support both. Math says everything is possible. So, now we have to say, is this available in nature? Bottom one is not available in our air. I am being very specific by saying it is not available in our air. Okay. We will go deal with that next class. Okay. So, what we have to do is go and look for what will happen really. Okay. So, how will I figure out that this is not possible, only this is possible? Only way to do it is in nature is to go for thermodynamics and say entropy, what is happening to entropy. That is the only way to say something will not occur in nature. So, I am going to write delta S S2 minus S1 is equal to, we know this expression, so I am just writing it as is, you know how to derive it also, we did it in the first few classes. We have this expression. Now, we have expressions for P2 by P1 in terms of M2 and M1, we have T2 by T1 in terms of M2 and M1, and Cp I can write it as gamma r by gamma minus 1. If I do all that together, I will get to a form where my S2 minus S1 is equal to this. But now if I substitute m2 in terms of m1 here, it will become very complex expression, and now we have to figure out whether there is more than 1 or less than 1 for each of those individual cases. That is very difficult to do. Instead we will go and do something different. Okay, it can be simplified, but we will not worry about that. All I did was I took a graphical method. Now we will go to that screen there. Okay, we will go to that screen. Now I have plotted this expression delta S by R, which we found out in here, and as a function of Mach number I am plotting from subsonic to supersonic, m1 actually. Okay, this is just m1. I do not know whether m1 can be subsonic or supersonic, so I am plotting it for all the cases as a function of delta S by R. I am plotting as a function of m1 for various gamma values. I do not know whether gamma is also mattering. So what I see is the blue line corresponds to gamma 1.1. Gamma can go only from 1.67 to 1, somewhere there. 1.67 is your noble gases or inert gases, monatomic species. So that is sitting something like this, it is on the bottom end here and it is also on the bottom end here, and what we are seeing predominantly is delta S by R equal to 0 when m equal to 1. Of course we know that already, because when m1 equal to 1, m2 equal to 1, there is no change in the flow, S delta S is 0. Otherwise I am seeing that delta S is positive for m1 greater than 1, delta S is negative for m1 less than 1. Okay, that is the important thing we are looking at here. Okay, so I am going to say from this plot, of course I have used all the expression math, I cannot directly argue out on board, so I used the plot. Okay, so now I am going to say here that this expansion shock is not possible, only compression shock is possible, because in nature only delta S more than 0 will be the only thing that will occur in nature. It can also be equal to 0, which will be this case m2 equal to m1, it is a very special case. Okay, so now we have come to a point where we can say that the compression shock is what is possible in our air. I am again specifically choosing the words, we will look at why next class.